Welcome to Neuroscience classes. This is the first video in this channel, Neurophysiology of Vision Part 1. How the brain constructs the visual image. In order to understand how a brain works, you need to go through 6 illustrations. It is through your eyes that you see the world. This is a cross-section of your eyeball. The mechanism has been compared to the operation of a camera. Like the camera lens, the intraocular lens of the eye focuses an inverted image onto the retina. As the person moves towards you, the image on your retina does enlarge. But what happens in the perception? When you're looking at the person walking towards you, and at the same time the image on the retina is enlarging. So in your mind you have to perceive this as the person is growing or enlarging. But in reality, you do not perceive the person itself as growing, but you perceive the person as coming closer. Here you can see some irregular shapes which do not appear meaningful to you. But when the same shapes are covered by an ink blob, you are able to connect the black background fragments. These irregular shapes now become little more clear. Brain assemble these fragments and make it into a meaningful object and perceives as 4 black bees. Even in the background, the brain can rebuild the seemingly meaningless fragments into meaningful things. Illustration 2. This is a famous illustration by Danish psychologist Edgar Rubin. As we focus on the black area, you will see the vase and white becomes background. And when we focus on the white area, faces pops up and black becomes the background. Illustration 3. This is Canisa triangle. You can perceive a white triangle in the center. I am highlighting the white triangle. You can see there is no real white triangle in this picture, but your brain constructs the image of the white triangle even though the outline of the triangle does not exist. Illustration 4. Here you can see an array of identical dots. Now, if we arrange the dots a little closer to each other in a certain pattern, like this, now the perception changed. Now you are seeing rows which are horizontal. Here we see columns. These 3 pictures contained the similar dots, but the proximity between the dots determine whether we see vertical or horizontal pattern. Color of the dots also creates the same pattern. Brain joins the same color dots and a horizontal rows appear and here vertical columns. Illustration 5. The edge of an object is also a powerful cue in the visual perception, like a children's drawing. Now you can recognize the objects clearly. Illustration 6. These two pictures are same but one is inverted. You see spheres or cavities. The decision depends on where you assume the light source. You can see some as spheres and some as cavities because the brain assumes that both columns are illuminated by one light source, the single light source, that is the sun. This is hardwired in brain by genetic and developmental process. So you saw 6 illustrations and hope you got a brief idea of how brain perceives shapes and pattern. But how does this brain produces the perception? It is accomplished mainly through 2 parallel neural pathways and concerned neural cell layers. I will give you a brief introduction on these 2 pathways. This is the eye. The impulses are taken to the visual cortex through the visual pathway on to the back of brain occipital region. From there 2 pathways, one to the posterior parietal cortex and the other to the inferior temporal cortex. Brain detects where and what the object is. By detecting the depth and motion, brain knows where the object is, and from form and color, brain detects what the object is. The dorsal and ventral pathways are also known as M pathway and P pathway. These 2 pathways we will discuss in the next part. So, to conclude, the brain constructs visual image of the external world and perceives the real world by processing impulses or the signals concerned with form, color, depth, and motion. That's the end of this introduction class of vision. In the next, we will discuss about the magnocellular and parvocellular pathways, that is the M pathway